overcome and what were the disadvantage of LSTM which you tried to overcome after making it hybrid?
No, sir. This is a basically a analysis. In CNN, there is no advantage, no in
It
in
means that basically what we are seeing is that you have done some
analysis
analysis of different systems, is it?
different
But
because my
so
system get
yeah,
90.
the accuracy is good.
No,
Accuracy
no, my
percentage we have
accuracy is
seen.
98%, I think, but in some papers accuracy is 99%. So CNN is good.
Sitama, see
Oh,
this
okay.
should not be good. Sometimes these models overfit that we do not understand, or maybe we have failed to understand, or maybe we have made them not to make them overfit. So that means we don't always go for the accuracy. 98, 99% accuracy. These are all okay. But my question was, unless if it's an analysis, then it's good. You have done an analysis, and then you have found out that some method is good and some method is not good, like that. Or maybe they are not so much accurate as the other method. But did some ablation study.
Some, sir.
Okay, where
Sorry, sir.
ablation studies. Ablation studies means that you need to reduce some layers and then see what results are you getting, so that it can take
Okay,
care of
okay,
those
okay.
overfitting problems. Okay.
So these
Or
layers, convolution layers or pooling layer.
in all the models you need to reduce some layers so that these overfitting problems are not there.
Okay.
Whenever you use such type of deep learning or convolution models, okay,
Yes,
you
sir.
should
Yes,
keep
sir.
this mind,
So that's
keep
and then
so
100%
just
accurate.
go for adding up the rate. Does not make any sense. Okay,
No. Okay.
you need to
Okay.
you
Okay.
need to justify that if you're adding some layers, then it is giving some more advantages than the previous year. See, whatever is 98% is quite good than whichever model gives 99%. That is not should not be our aim. That we should be in that case we should use some other evaluation matrix to always do ablation.
Okay,
Okay,
sir.
that's all from my side. Also, Banerjee.
Uh, Sridhama, actually, what you did, that is CNN, LSTM, the hybrid model, CNN technique. Actually, I am sometimes bit of confused that why people I am bit of confused that whenever the other techniques, STM, RF, okay, some other similar techniques are uh, such investing. Lot of other techniques are there of benefit.
Sir, actually, this is my first paper.
Last paper, this is not the question. Whenever you are going to consider a particular problem, basically each and every paper is basically nothing more than a problem. Take care about a problem. At that time, you are going to choose. That has to be clear at first to you only, right? That is why I'm raising this
Okay, sir.
question. So, right. So this is not the question of first
Okay.
paper, last paper. Okay. So there are
Okay,
other
sir.
techniques.
Yes, sir.
You may choose two also, or you may choose four also.
Hmm.
But
Yes, sir.
justification should be there. Also required. So I am expecting that during whenever consider the techniques, you need to find out. I do believe out. Receive. Okay.
Okay, okay, sir.
Thank you.
Thank you, sir.
So we can move. You can stop sharing. We can move.
Yes, sir.
We can move to the next paper. The next paper is 17.
Session chairs, Dr. Jyoti and Dr. Kaushik. Hello. Can you
Yes,
hear me, sir?
yes, yes.
Okay.
Yes,
Yes,
hello.
we can hear you.
Actually, more papers to present.
Okay. Okay.
Okay.
Sure. So 17.
Hello, Dr. Shandip. I think
Yes, absolutely. Speaker, please start the session.
Oh, okay. There is a they are. I think paper ID 10 should present now.
Actually, we You can mute yourself.
Paper ID 10, Mr. Sayantan, you please share your screen immediately and start the presentation. Start defending your book. Mr. Sayantan.
So yeah, I'm just sharing my screen, sir. Just give me a moment. Let me know if you can see my screen. Is it visible for everyone? And am I audible?
Yes, you are perfectly visible and audible. Continue.
Thank you. And how much time do I have approximately?
Maximum 8
8
minutes.
minutes.
Okay, thank you.
Within 20 minutes, if you wind it up, it will be better for me to adjust.
Okay,
Okay,
Mr. Maximum, you take 8 minutes.
okay, wait. Now the problem is the moment I have two monitors. 1 second. So just a minute. It's in the full screen mode, right, for everyone?
Yeah,
Okay,
yeah,
thank you.
perfect.
Thank you, professors and fellow researchers. Good morning, greetings from Germany. My name is Shantan. I'm a researcher and also running a startup. Presenting this paper ID 10, which is a industry-oriented use case by my dear friend and colleague Shomit and Chetan and Shorab. Unfortunately, Shomit, Chetan based out of US holiday for Thanksgiving and probably midnight. So I am doing the presentation. And I'll also add a disclaimer that I'm not extremely deep. So if there are very specific questions that you have, I would have to park it for Shomit, Chetan, and Dr. Shorab and Rajesh. So let me go right into the paper, which is harnessing AI for a cash flow forecasting. I have these list of items that I would cover: the background, motivation, contributions, results, and more importantly, probably I will talk a bit about also the future work on explainable AI and LLM based explanations on which I am working by extension than the current paper, and of course, conclusions and also questions that you can have. So, a bit of background into cash flow analysis, as you can guess from the English meaning of the word. So, if you look at large corporates, so for a C-level executive, at how much money I need to have in my bank account, not in my bank account, but the company bank account, so that employees are paid on time, and of course you have vendors from which you are buying goods and services. So imagine if you are level data for about somebody, a stock, a price going down, or a climate change, or a political leader not agreeing on certain things or geopolitical. So this piece is socially available, proprietary systems, as you like Oracle or SAP, on which you get this data. And the main contribution, if I would say, comes down to, can we sort of benchmark different state of the art models to see that which the idea is, of course, as I was listening to one of the earlier conversations, was not to beat, not very focus often in such use cases. Often, not only do that why that model made a certain thing that we are doing right now, I would say you could say sales, economic data providers were publicly scraping like MSN. These were actual payments, but the invoices were obfuscated. So the personal moved, and this is our then cash forecast to do the entire pipeline piece. Let's go down directly to the results. And probably I didn't speak about. I was saying benchmarking based on different models. Okay, now when I say different models, the motivation was we use classic time series windowing methods. So over, for example, a curve of values when the horizontal axis is time, just imagine is a price. And now this is not one because there are multiple features. So it's a multivariate data, right? So you could use different ways of averaging it. So we followed some steps on how multidimensional data could be benchmarked. So we have a classic RIMA, GRU, LSTMs, where we used some benchmark models and also did a bit of hyper. Always black magic, dark, you say. So that piece was done. And the idea is that we wanted to look at classic models as well as deep learning models. Of course, the worst part is, even though the performance wise, so this is my target variable, dollar. So we are trying to predict the dollar value. So the minimum the error is, the better it is. The problem is that these mostly weights, so it's optimizing a function. Unfortunately, I cannot tell a business user who is not a machine learning data scientist to say that, oh no, I and 1181. Instead, ARIMA, even though the RMSE is better, I would say what we found when we actually presented this to the business users, it is sometimes easy to say that something like you go to Amazon and you explanation goes, you who heard so recommended this song. It's based on similarity. The recommendation is happening. In ARIMA, I could say this prediction because there was this time period where we found there was a drop and then followed by two hikes, and now your prediction is. What we found was even models where real life scenario, it's very difficult for a business user to digest the data. A lot of moving parts in the element probably which I have missed. Apologies for that, because what I am doing and helping the team out there is actually this work. So happy to tell you that we are really globally connected. And a lot of work, for example, I can see on the screen, like at the hyperparameter optimization. There were a lot of stuff on the engineering side which was done by the team, which was,
Okay,
I won't say that
Sukanta,
I can't claim.
you need to finish within a 1 minute because we
Yeah,
have
yeah.
a
So I'm just here, sir. So I would take a pause and I would welcome any questions that you.
Can
Okay.
you go to the first slide?
Yes.
Different types of techniques, but
Mhm.
for
Mhm.
improved cash flow
Mhm.
forecasting, it is basically
Please start. Professor Banerjee, are you hearing? I'm not hearing.
no. Actually, I am also not able to hear anything. So I am requesting Dr. Shandip De kindly take initiative to start the session. Otherwise, the keynote speaker, we can see that uh, the speaker is already joined. So we should start and end the session as soon as possible.
Is it visible?
Yes, yes.
Good morning, sir. Energy, student of Masters in Computer Application at Computer Science and Technology Department in North Bengal University. Along with my teammates, Sumit Kumar Yadav, Punkit Dada, and under the guidance of Dr. Mohammad Aziz sir. There are lots of threats in our today's digital landscape. But the most challenging threat is deepfake. They are AI area that mimic the real people and making them difficult to distinguish fake and original. But increasing of that spread many threats and become more in political. So addressing the challenges. Such as images, videos, and audios that conflict mimic the real world content. They are created using guns, so it was difficult for us to distinguish between original and the fake. But defect generally used for the good uses, like in entertainment, for visual effects, so that it makes it bring back the act of, and in education it is used to explain the historical incident. But it has also some misuse. The people making videos and audios to give threat to the others and spread the fake news, particularly in political manipulation. And these the rapid misuse of the threat to individual privacy and public trust in media. This is too important to urgent development of robust framework to stop this. In our work, we have conducted comprehensive review of the traditional and AI-driven deepfake detection methodologies, identity research gaps, and particularly in detecting the advanced deepfake. And we propose to future direction to focusing on scalable and particular solutions. Deepfake are powered by GANs, or Generative Adversarial Network, which is created hyper-realistic content. This network was introduced in 2014. In this network, there are main two components. Uh, one is a generator, and other one is discriminator. Generator create the fake or duplicate content, and the discriminator is try to understand the distinguish between real and the fake that make by generator. And the generator always try to make full of discriminator by making the content, and discriminator always try to distinguish between real and fake data. In competition with these two method, the generator improving over time, and it makes the more accurate deepfakes. And the other technologies like face forensics, deep video portrait, or fast total model, motion model, the make this makes the deepfake more accurate day by day. And it is these technologies are mainly use CNN and RNN to deepfake images. In this defect detection, we use mainly two types of methodologies. First one is traditional based methodologies. In this traditional based methodology, there are two types of methodologies, that digital forensic and watermarking. Digital forensic is like examining the pixel level and the focusing on the facial image and try to recognize that defects. And the other and the watermarking is uh, mark like a hidden mark in the video or images, and that embedded to verify the authenticity. For stop privacy, in cinema now, people use the watermarking to stop the piracy. But in this traditional methodology, the accuracy level is not good because they use the pixel level. So we introduce the AI-based methodologies. So AI-based methodologies has mainly two components, CNN and RL, that are part of deep learning. Structured read data like such a pattern between the images to recognize the defects. Other one is RNN or recurrent neural network. That is also a part of neural network. Uh, this is basically designed for the sequential data like video or time series or text that identify the unnatural movement to enhance performance of the to enhance the performance or enhance the accuracy. We use a third models that called hybrid models. In these models, we combine AI and traditional technique for higher accuracy. And by studying these previous models, the currently introduced some models, the advanced models. The main there are some example is first one is vision transformer or and efficient net. These models utilize the pre-founded models and extract the high-level features with the superior accuracy. The next one is fission technique. In